Suppose I wanted to describe my motion today. I wanted to be able to describe it in such detail that you could recreate it exactly. What would you need to know? Well, you would need to know where I started. If you want to create it exactly, you need to know where I started. And so, without any other reference here, we're just going to call this some initial position. I could also write it with a sub-0 there or a sub-O. It depends upon my mood. So I have some initial position. The next thing is you need to know which way did I move. So I moved in some particular direction. So notice that the key word there, a key word is direction, which means I'm dealing with vectors here. So I move in some direction at some speed here. So I have a speed plus direction. I have a velocity, and this is position. Now, how long do I maintain that velocity? Am I moving at a constant velocity? No, probably not. So my velocity is changing. If my velocity changes, so if there's a change in velocity, that means that I have acceleration. Does my acceleration stay the same? Well, probably not, because I am going to speed up and slow down. It's not like I started moving this morning and have gotten faster and faster as I go, or moving in circles. So if there's a change in acceleration, that means I'm going to have a jerk. This is an official, unofficial term that is acceleration is accepted internationally, jerk is not. However, it is the common term in the US at least. There are a couple other terms depending upon your country. Is the jerk constant? Well, not necessarily, but we'll get into that in a moment. So in order to describe my motion, we need to understand how my position changed, in other words, my velocity. We have to know how my velocity changes, we have to know how the acceleration changes, and so on in order to get a full description. And so these are all terms that become necessary when dealing with describing motion. And so starting out here, we have position. And now there's another video that I'm going to ask you to sort of look at, which involves, it was originally done for a different group. However, the vocabulary stays the same. Velocity, acceleration, jerk. Now, if jerk changes, this is colloquially known as snap. If snap changes, this is known as crackle. I'm sure most of you know what the next one is. If crackle changes, this is known as pop. And then the last one, I had a student who suggested splat for the next one. But this I've seen in textbooks. It has been in various published papers. These terms right here, which I assume was devised by some grad students who were eating cereal one day, these have been in 2 published papers. They're not accepted internationally, just as jerk is not accepted internationally. There are 3 other terms that are commonly used. But snap, crackle, and pop have been in 2 published papers, which is one of the steps needed in order to get international acceptance. And so it's on its way. When I first heard about snap, crackle, and pop, it hadn't even gotten published yet. So at this point, that's changed. And splat doesn't necessarily mean you're going to die. I mean, if I'm wobbling back and forth like this, if that's can be described by sine motion, then there's definitely a splat involved. I mean, all of these are constantly changing. Now, from a calculus point of view, if that is x, velocity is dx dt, acceleration is dv, this is v, that's a, acceleration is dv dt, jerk is equal to dA dt, and so on. Now, some other notation here is, since velocity is dx dt, we can also write that as x dot. The dot notation is specifically derivative with respect to time. And so this is just the slope, which is what a derivative tells us from a graphing point of view, slope of my position versus time graph. Acceleration is dv dt, as just mentioned over there, so v dot, or x double dot. So this is the slope of which x double dot is d squared x dt squared, which is the slope of the velocity versus time graph, which is the curvature of my position versus time graph. Jerk is d a dt, which can also be written as v double dot or x triple dot. And so you can see that generally you use dot notation, and there are a couple other various notations that can be used for these mathematically. So it's not like you typically see snap is x with 4 dots on it. Generally what you would see is d for x, dt4, or you potentially also would see for a generic somewhere in this list, dnx dtn for the nth derivative. And I think that's common math notation as well, not just physics thing. It's been a while since I've had the formal math class. All right, so jerk is d a dt. So this would be the slope of acceleration versus time, the curvature of v versus t, velocity versus time, and I don't know if there's a word for it, whatever it is for position versus time. If you know what it is, let me know. I'll add it in a later version of this. Conversely, now some of you have already had Calc 2 and some of you have not. And so if we're sort of working backwards, if I take derivatives, I'm finding slope, but if I'm going backwards, as indicated in another video, it's area. And so I can also write that acceleration is the antiderivative of jerk, which is the area. Technically, change in acceleration is I should write it that way. Change in acceleration is equal to the antiderivative of jerk, and this is area under jerk first time. Velocity, change in velocity is the integral of a dt, so it's the area under acceleration first time. And change in position or displacement is equal to v dt. So as we look at this list here, and the next thing is just more of a visual than strict math. Let's sort of rewrite those terms again. So I have position, velocity, acceleration, jerk, snap, crackle, pop. And I'm going to throw a splat in there. If I'm going in this direction, I'm taking the slope. If I'm going in that direction, I'm doing area. And technically, the area under the jerk curve is the change in acceleration, not the acceleration itself. You need an initial condition in order to be able to narrow that down. And that is some of the terms of motion. And I'm going to leave it there.